Welcome. This is video 5 in the series about making adaptive woodwinds, and this particular video is about the technical methods we use in making all the parts and the keys and such. It is not a general woodwind making course, but I'll talk about that in the next video if you're interested.
How do you make key parts?
Well, our methods are very different from a production environment. Much simpler and, in a way, much less efficient. And the very most simple way is to cut them from sheet. And I have this little trick here. I design them in CAD software like Rhinoceros. Then I print it 1 by 1 scale, glue it on a metal sheet. And then I punch for the middle of the hole, I drill the hole, and then I cut out the rest of the metal sheet with a small bend saw. A bit of filing and you're ready. I have another method here, again very different from what you would use in the industry, but very good for finding locations. And so I use a piece of steel wire, which I first straighten, and I make a little hook on the end. And that hook will fit around the hinge of the key, or you make a piece of a hinge yourself. You bend the steel wire to find the relevant points, and once you found them and you tested them, you can transfer it easily to paper. Or what you also can do, you can transfer straight to the sheet metal. From there, you design the key. And you can either paste the paper to the sheet metal, or use another method. And here I have a picture of the working key.
Do you use 3D printing in making the adaptation?
Yes, pretty much. One way of using it is to validate the design that you made. So I'll print in FDM or resin to see if it works. And I also use the 3D printing, resin printing, for casting. More about that later. I'll make lots of tools, and I'll also later with cup making, I'll show you a little tool 3D printed that I use for fitting keys. And of course, lots of instrument support and holding things. So yes.
Do you cast your key pieces?
Yes, I do some casting myself, but most casting I outsource. Casting myself I can do with the Delft method, very simple method. You do need a strong flame to melt the metal. And it works very well in combination with 3D printing, because you can 3D print your model and put it in the casting clay. It gives a bit of a rough surface though, but works easily. Rather time consuming, I must say. When you need high quality castings, it's best to use investment casting, lost wax casting as it's also called. You can do it yourself, lot of equipment, and it takes also quite a lot of experience. So most instrument makers outsource the casting. A very good material for casting in using resin printer is X1. But not all casters are happy to work with that material, so you should communicate with your caster what printing materials, what resins you can use, and that they can accept, because the different materials have different burnout schedules. There's also another way to get to a casting, and that is you send a piece either in metal or perhaps 3D printed, and they make a rubber mold with that. And that is and that is filled with casting wax, and from that they do the casting. Very nice method. But of course you have the cost of making the mold. There is considerable shrinking, can be as much as 10%. But if you need the same casting again and again, this is a very useful method, and I used it, for example, for the crowns of my flute head joints. When you are casting, you might as well cast more pieces together. So here's an example of the key arm and the touch piece cast together in one piece.
How do you make keycaps?
Yes, very important. Well, the smaller ones, they're easiest to turn on the lathe from solid. If you need only few, and if they're small, works very effective. And in this photo, there's a flute keycap and a so-called mushroom with a slit in it, and one side fits the tone hole and the other one fits the inside of the keycap. It has the height of the pad that you will be using, and it's very nice that way to hold the keycap in place on the instrument when you are fitting the key. Another way to make keycaps is to press. If you have a hydraulic press or another type of press, you need to make some tooling, but then it's a very effective way, and with very little material waste. The most used method is to salvage them from an old instrument.
How do you join key parts?
Well, key parts must be joined with silver solder. It's the only way, it's the only material that's strong enough. But silver solder can mean different things to different people. So we use this on the top of the photo is brazing alloy, which melts at around 640 degrees centigrade. Nice to work with and a bit pinkish in color. But when you have real silver keys, like on handmade flutes, then you have to use what the silversmiths call silver solder. And that is solder which is also silver colored, with a higher silver content. And what they call soft solder is not what we call soft solder. For the silversmiths, soft solder is a silver solder with a fairly low melting point of around 650 degrees centigrade. And their hard solder goes up to 770 degrees centigrade. Then there is our soft solders, and the most used and recommended is a tin silver alloy with a melting point of around 220 degrees centigrade. Keeps it shine very well, pretty strong, and lead-free. But sometimes there are already all sorts of parts soldered on the body of your flute or saxophones, and you don't want them to fall off when you are soldering. So it's good to use a soft solder with as low a melting point as you can find. And there you use traditional lead tin solder with a melting point of around 160 degrees centigrade.
How do you hold parts together while soldering?
The finishing, the most used tool for this is the soldering jig, and I couldn't find any picture of it on the internet. It's used in the industry. You just slap the parts in it, pull out your flame, and you're ready. Very simple, but not very useful for our methods of working, because we don't use the same jig again and again and again. One thing is binding wire, which is very time consuming. I don't like it, but it's important to use binding wire sometimes to stabilize existing parts. For example, when you're soldering on the body of an instrument, of a let's say a saxophone, you use binding wire to stabilize all the nearby parts, so they won't come undone while you are soldering. For key soldering, I have this adjustable jig that I made myself, and it's based around a lab lift, which is the thing with a wheel you turn and it goes up and down. And on the top it has a soldering sheet, which I buy from the silversmithing shop. And there is also a thing, I don't know what it's called, a sort of attachment, so I can hold the key in the right angle while soldering. And of course 2 points nicely centered to hold the key on the ends of the hinge. I also have a photograph of the other side so you can see that. Works very nice. The lap lift is unfortunately not very precise, but I made lots and lots of keys on this instrument, on this tool, so that's why it looks so old, because it is old. I have another soldering jig, which is here, and it's based around a very precisely working but expensive 3D stage, which you can buy on all sorts of places. There is a small holder which holds a sort of round thing on which the key cup fits, and it is threaded so you can adjust the height up and down. And the 3D stage can move X, Y and Z also. And on the top of the 3D stage there is a piece of aluminium sticking out, and that holds the hinge. So you can adjust the hinge in 3 dimensions, and you can adjust the cup up and down, and you can solder very precisely with this machine. It's a bit costly to make, but if you do a lot of instrument adaptations or flute making or so, this really pays for itself. For manipulating very small parts while you are soldering, I have this attachment. It's a Fisso articulated arm with at the end parallel clamps and a pair of tweezers, and that works very well for moving about, a little bit to the right, a little bit to the left. These different types of adjustable soldering jugs are my own invention, but they're not patented, so you're free to copy them.
What flame do you use for soldering?
For silver soldering, you need a fairly big flame. So your small butane torch probably won't do the job you need. Fairly good flame. Most makers use either propane or acetylene. And here I have a propane and oxygen flame, which will even do melting in case you will do some casting. In my jig here, it is shown with a closing off apparatus, which will close off both oxygen and the gas when I put my torch on the holder. Unfortunately, it doesn't close off 100%, so at the end of the day I still have to close the gas and oxygen bottles. For soldering on the body of saxophone, I use a high-powered heat gun. Works not as fast, but it's very reliable, and it doesn't burn the metal as much as a flame does.
What is a setting out machine?
This is my setting out machine that I made myself, and it lives in this drilling machine. On the back behind the chuck, there's an angle plate where I can set out the angles, so I can use it both for setting to make an instrument or to measure an existing instrument. On the other side, at the centering point, I have this special centering point which has a spring behind it. So if I use the setting out machine for soldering pillars, for example, then this compensates for the expansion of the instrument when you heat it. I have different tools to measure holes and pillars in the right angles. And I put them in the drill chuck and you put them over the instrument. So you can measure, for example, the location of the pillar, but you can also hold the pillar for soldering. Of course, this only works well when the instrument is centered exactly under the middle center line of the chuck. And for that I make this tool. You can also buy them here and there. I couldn't find one that time, years ago, so I made it myself. So you also use the setting out machine for drilling holes in instruments and also drilling for the pillar locations. Then of course, after you drill a hole, you must mill a flat on the top, for which I also use homemade tools. And to cut a recess so the pad will sit on a small rim. On the right of this photograph there is you see a small, also homemade milling bit with a brass pilot that is used for exactly centering in the tone hole for cutting a tone hole insert. Here's a very nice use of the setting out machine. With an end mill, I mill flat recesses in the body of the instrument, in which I glue threaded bushes, and these hold the base for a key. I explained about this method of key making in video 3. This is the most simple. It's a setting out machine, or nearly the most simple. It is a non-copying jig. The copying jigs have pins, so you can really quickly locate the positions and the angles of an instrument, and that's what you use in small-scale instrument manufacture. Larger scale instrument manufacturers use 4-axis CNC machines.
What more machines do you use in the shop?
The most important machine, of course, in the shop is the lathe, good old lathe. Buy the best one you can afford, because it has so many functions, you can do so much with it. Of course, drilling machine is very useful. I have this small bandsaw, which is also incredibly useful. And I use it in combination with a metal cutting blade, and that'll cut all the materials for me. Of course, then there is the belt sander, a polishing machine, a spark welder, PUK, it's called, the brand. Works very well for temporarily joining silver and nickel silver prior to silver soldering. Unfortunately, it doesn't join brass very well. And then, of course, I have my 3D printers. I have a Prusa Mark IVS and the Hay Gears resin printer. Also, for me, indispensable tools. Of course, there's much more possible, but as a small maker, you must limit yourself. If you're interested in developing yourself in this field, please watch the next video too. This was all about the technical methods for making adaptive musical instruments. If you have any questions, please ask them in the comments. I hope you watch the other videos in this series too. And bye bye. Thank you for watching.